This video will be about WebSockets, which are useful for updating content without needing to refresh the page to detect changes. And yes, this too is in the proposal stage, and it will be implemented after pagination and infinite scrolling are supported. So with that being said, if you're not familiar with real-time apps, they're actually more similar to REST APIs than you might think. So let's take a look at a typical REST API setup. Here we have our API server, which exists at some domain, and we make HTTP requests to specific endpoints to interact with our data, get, put, post, etc. And when we make a request to one of the endpoints, the server responds to that request and sends us data. And then we do it all over again once we need to do something else. WebSockets are very similar conceptually, at least for the purposes of this diagram. They also have a server endpoint, though it's going to run on a different port than your REST API, and instead of endpoints, you have rooms that you subscribe to, like posts and comments. The biggest difference is in execution. Instead of making a request and then waiting for the response, you subscribe to a room, and that connection stays open. Then the server calls you whenever it has data that you requested to be notified about, instead of you calling the server as you do with a REST API. It's also important to call out that the responses do look a little different as well. So once again, here's the REST API concept, and here is the WebSockets concept. The point of this is really just to highlight that conceptually, the same pieces exist in both the REST API model and the WebSockets model, they just change name and form. The core challenge with this is integrating WebSockets into the existing REST API action data flow naturally, as duplicating actions for every real-time endpoint would be tedious and error-prone. So let's take a look at how Lore is planning to implement that. For context, let's run through the existing REST API data flow real quick. So with the REST API setup, the components invoke action creators, which make requests to the API server and handle the response. Then they dispatch actions, which are picked up by the reducers in the store, and then the application updates when the state changes. By comparison, here's an example diagram to show how Lore intends to integrate support for WebSockets. The plan is to create a set of blueprints that live alongside the REST API blueprints that already exist currently. The key difference is that the data the server sends to us through WebSockets doesn't match as cleanly to the actions that we want to dispatch. So the challenge here is implementing support for WebSockets in such a way that nothing else in the application needs to change, and the existing reducers can continue to function unmodified. So given the previous diagrams and discussion, the WebSockets implementation will likely be a combination of action creator blueprints that know how to subscribe to rooms, as well as a series of user-defined mapping functions to help Lore convert the WebSocket messages into an action. Let's take a look at what that might look like. And we'll start by diving into the config folder at the root of our project structure. Like everything else in Lore, WebSockets will end up with its own config file. And since Lore is trying to make things simple, the goal for the interface is to be a switch that you turn on or off, and WebSockets will then piggyback on your existing action infrastructure. By default, WebSockets will be disabled, so to use it, you would first have to turn it on. Once you do, you'll need to provide the URL or port that the WebSocket server is running on, and then supply a function or set of functions that knows how to convert a WebSocket message to its corresponding action. And we're going to focus on that function for just a minute. So to reiterate, the purpose of this function would be to convert the WebSocket message into the corresponding action. To do that, you'll need to map the room and verb into an action type, and map the verb to a payload state, though most of the time this will simply be resolved for data coming from other users. You'll also need to extract the data from the message that we want to send to the reducer. Additionally, like everything else in Lore, this WebSocket config will also be overridable on a per model basis as well, in case you're interacting with multiple WebSocket servers or the mapping pattern changes on a per room basis. Alternatively, if you only want to subscribe to a specific piece of data and not an entire room, Lore will supply functions to subscribe and unsubscribe to data, such as when you only need to be notified during the lifecycle of a specific component. All right, so known areas for future improvement. So I'm not going to read this. Feel free to pause the video if you want to. But basically, polling is a way of faking real-time support by making requests to the API server on a timer. While I believe Lore should provide support for this, as many applications can benefit from a pseudo real-time implementation, it's important to call out that polling does have limits. It's really more of a band-aid or interim solution, and not something you should or really can depend on if your application really does have a high rate of change. It gets especially tricky if you're polling at a high frequency and your API is slow to respond. Browsers have a limit to the number of concurrent AJAX requests that can be made to the same domain, and under these circumstances, your application can stop being usable as requests become queued up. And with that, let's review the rundown. WebSockets are important because they can provide an improved experience, especially for team or collaborative apps where multiple people interact with the same data. The core challenge is integrating WebSockets into the existing Action Reducer data flow naturally so that it can easily be turned on or off. While this feature is still in the proposal phase for lore, the approach the framework plans to follow is to create a series of WebSocket blueprints and then ask for help mapping the messages to actions.